going to talk about applying the properties of mid-segments to solve problems, okay? Mid-segments, we're talking about triangles. And a mid-segment, first of all, we need to understand what a mid-segment is. Sorry, I'm going to change that. Connects the midpoints. I should expand that a little further. We're going to use it with triangles. We could connect mid-segments of any figure, okay, quadrilateral, pentagon, whatever. It would still be a segment connecting the midpoints, okay? So mid-segment is a segment that connects the midpoints of two sides. We're going to stick with triangles because that's what we are going to use it for. Okay? So if I have a triangle here, and if I know that's a midpoint, that's a midpoint, and that's a midpoint, okay? Mid-segments then are going to connect these midpoints. So those are three mid-segments. Okay? We have three mid-segments that are connecting the midpoints of two different sides of a triangle. Okay? Any questions on that? Okay, I'm going to pause this to write down the triangle mid-segment theorem, and then I'll turn it back on and we'll get going again. Okay, just to make sure you can read it, it says if a segment joins two midpoints of a triangle, then it is parallel to the third side and half its length. Parallel to the third side and half the length. So, if I put a triangle on here, and if I pretend that that is so here's my triangle ABC. What do these marks I put in red here mean on this line right here?
Those two segments.
Okay, those two segments are congruent, right? And these marks here mean that
Those two.
those two segments are congruent, right? If they're congruent, then what does that make these 2 points? Midpoints, right? Remember the definition of midpoint says that it's a midpoint of a segment if and only if the distance from the endpoints to the middle or to that point are equal. Okay? And so we're saying they're equal, so therefore it must be the midpoint. All right? So that makes that blue line a mid-segment. This theorem says, since that's a mid-segment then, let's label it, MN. And we can talk about it. What can we say about MN then? Okay, so we could say that segment MN is parallel to segment AC. Okay? What if I know that MN is 12 units long?
Then AC is 24.
Okay, that means then that AC, no symbol means what? The distance from A to C. Okay, AC then is going to be 2 times 12 long, which is 24. So this length here is always half as long as this length here, as long as these are the midpoints. Okay? Nick, do you have a question?
I was just gonna say could you write like MN is like equal to 1/2 of AC?
Yep, that's exactly what we could write. We could say MN is equal to 1/2 of AC. Or we could turn that around and say AC is equal to 2 times MN. Okay? So that's exactly what we need to understand. There's 2 parts to this. Anytime we know that a segment of a triangle is connecting the midpoints of 2 sides, then that means that segment is a mid-segment. And this theorem means then that it's going to be parallel to the third side and half as long. So if I know how long the third side is, then I know how long that is. Okay? It's going to be half as big. If I know how long the mid-segment is, then I know the side is going to be twice as long. Okay? Any questions on that? In case you have not seen it, here's our calendar for the week. This is, may not be in Schoology yet for you, but I will try to get it in today. Okay? This is in 6 periods. So I can't just simply paste it over, I have to redo it again for 6 periods. Okay? If there's a better way, then I'm unaware of it. If you know of it, you can tell me.